Welcome to the video, the trapezium rule. We already know that the area under the curve y is equal to f of x in the interval from a to b is found by the integration of a to b f of x d of x. But sometimes you are given some equations that you have not learned how to integrate. So we are looking for a numerical method to find an approximation for the area under the curve from point A to B. Now, to that end, we subdivide the whole region into n intervals. How? By having h, which is the width of these trapeziums that we have made, by dividing the whole interval from b to a, so b minus a divided by n. So we subdivide the whole region, the whole interval from a to b into n intervals, and for each interval the width is b minus a over n, denoted by h. As you see, you have a trapezium from xo to x1, which is h. Then these two sides are parallel with each other. So this side, which is shown by yo, is actually f of xo. If you put this point in the equation of f of x, you will find this point, and as well as the other points. You put x1 in the equation, then you find y1. So the whole region is subdivided into n intervals. Now, then area will be equal to. Now, instead of directly finding the whole integration by one of the integration methods that we have learned, which is impossible here, so instead we have to use a numerical method. What is the numerical method used here? Is the trapezium rule. What does it mean? It means that subdivide the region into different trapeziums. Now, I one by one find the area of each trapezium, then they add up to the whole region, which is an approximation for the whole region. Now, for the first interval, we know that area of trapezium is the sum of parallel sides. So this side is yo, the second side is y1 divided by 2 times height, which is the width, is denoted by h here. Now, for the second one as well, it would be here, this side, as you see here, is y1 plus y2 divided by 2 times height of this trapezium, which is again h. For the next one, now for the actually third interval, as you see, this side is y2, then y3 divided by 2 times height, and we continue until the last interval, which is yn minus 1 plus yn divided by 2 times height. Now, these are all the trapeziums which will give you the whole region. Now, as you see, h over 2 is common to all of them. So I factor h over 2. Then what we have here is yo plus y1 from the first one, then from the second one y1 plus y2, from the third one y2 plus y3, and we continue till the last interval yn minus 1 plus n. Then it will be equal to h over 2. Now, yo is repeated once actually. As you see, it is this wall is the first, one of the parallel sides of the first trapezium. Now it is repeated once, but the interior intervals are all repeated twice. Why? Because this y1 is one of the sides of the trapezium on the left hand side as well as the right hand side. That's why all these interior sides from x1, from actually y1 to yn minus 1, all of them are repeated twice because they belong to two trapeziums. So I write 2 for the other ones. 2 y1 plus y2 plus until yn minus 1. Then the last interval yn is actually unique. So I write yn. So now as you see, it is the formula made in order to find the area under this curve when you don't have any other methods, actually known methods that you have learned to find the exact value of integration. So we use this trapezium method, which is an approximation of the whole region. So, and what is h here? So I write a here. H is actually b minus a divided by n. Example number 1. As you see, there is a curve of equation y is equal to x minus 2 ln of x. It says use the trapezium rule with two intervals, so the number of intervals will be 2, to estimate the shaded area. State with a reason your answer is an overestimate or underestimate value. Now, it says two intervals, so h, which is actually the length of a step, will be so the whole interval, which is 3.5 minus 0.5, will be divided to 3.5 minus 0.5 will be divided by two intervals, so which is 1.5. Now it means that you should move at the step of 1.5. So you have in the middle after 0.5, you move 1.5 step ahead, you reach to 0.2, then 1.5 step again ahead, which gives you 3.5. So now you have two intervals. Now you are supposed to make trapeziums here. As you see, one trapezium here, then the other trapezium here. Now find first corresponding y-coordinate of this point. For 0.5, the y-coordinate, if you put in the equation, it will give you 1.8863. And for 0.2, if it is replaced in the equation, it will be 0.6137. And for this point, 3.5, the corresponding y-coordinate will be 0.9945. Now everything is ready to use the trapezium rule. So area will be equal to h over 2. Now I use the formula for this one. We know that it will be yo. We have just one interior wall, which is 2, corresponding to 2. It is yo. Sorry, let me write it here. This point is yo. The middle one is here y1 and y2. So yo and the last one y2 are repeated once, and the middle one is repeated twice. Now it will be equal to area is equal to h, which is 1.5 divided by 2. Yo is this wall, which is 1.8863 plus twice the y-coordinate corresponding to 0.2, which is 0.6137 plus the last one, which is 0.9945. The answer will be almost 3.08115. Now to state that whether it is overestimate or underestimate, as you see, the curve bends upwards and the trapeziums that you have made are above the curve, as you see. So that's why we can say that it is an overestimate because the curve bends upwards and the trapeziums actually goes above the trapezium, you see, in this interval and here as well goes above the curve. So the answer that you have found is actually a little bit more than the actual area under the curve. Example number 2. The diagram shows the curve y is equal to 2 square root of 4x minus x squared. Use the trapezium rule with 4 intervals. And the number of intervals is 4 to estimate the value of integration of 0 to 4 to root of 4x minus x squared d of x. State with a reason whether this is an overestimate or underestimate value. Now, so h, which is the length, the length of each step, will be upper bound, which is 4, minus lower bound divided by 4 intervals, which is 4, so it is 1. It means that you should move 1 by 1. Now, so after 0, 1 step, 1, 1 more, 2, 1 more, 3. Now, let's form our trapeziums. Now, another trapezium here. Now here. And this one. As you see in the first and last one, as you see, the curve cuts x-axis. So instead of trapezium, you are having actually a triangle instead. But it doesn't matter if you use the formula of trapezium. Again, because this side is 0, it will be converted to area of triangle. But use the same formula. It doesn't make any differences for your answer. Now, here, again, I find corresponding for each point for y coordinate, it will be 0. For this point, if you put 1 in the equation, it would be 2 radical 3. For this point, it would be, if you put 2, it will be 4. For 3, if you put again, it will be 2 radical 3. If you put 4, again, it will be here 0. Now, trapezium rule for this case. So area will be h over 2, first interval and the first one and the last one, which is y4, are written once, but the interior ones, y1, y2, and y3 are repeated twice. y1, y2, y3. Now, so area is equal to h. H is actually the width of each interval, which is 1, then over 2. yo, which is this side, is 0 plus 2. y1, which is the length of this one, which is 2 root 3 plus y coordinate corresponding to this point, which is 4. Then y coordinate corresponding to this point, which is 2 root 3 plus then y coordinate corresponding to this point will be 0. Now it will be 4 root 3 plus 4, which is almost equal to 10.93. Now, to state whether it's underestimate or overestimate, as you see, these trapeziums, the curve actually bends downwards. And you see, if you notice here, the trapeziums are under the curve. Under the curve, there is, some empty space here. So this answer is an underestimate for the actual underestimate. as the curve bends downwards. It bends downwards, and trapeziums are actually below the curve. They do not completely cover the curve. That's why it is an underestimate for the actual value.